The E at T is 60. The L equals 1 and the R equals 50. One more, the capacitor is 10 to the negative 4. And the initial conditions, the I1 at 0 equals I2 at 0 equals 0. Okay, replace the number. This gonna be 1 and the R is 50. The E is 60. R is 50. The C is 10 to the negative 4. So simplify and get things cleaned up. We should get, I'm going to write as the prime. So I1 prime plus 50, I2 equals 60. And the second one, the 50 and 10 to the negative fourth, simplify to be 1 over 200 and multiply all by 200. We get I2 prime plus 200 I2 minus 200 I1 equals 0. And then we're going to use the inverse, the Laplace transform, and we deal with the first order, not too bad. So we're going to use the capital I to represent the Laplace transform of each I1 and I2. So Laplace of the lowercase I1 is the uppercase I1. I2 is the uppercase I2. And then the Laplace transform of the I1 prime is the s multiplied by the uppercase I1 minus s to the 0 times I1 at 0. Laplace of I2 prime is s I2 minus s to the power 0, I2 at 0. And very nice that I1 and I2 at 0 is 0. Then we just have s times I1 and s times I2 for the Laplace transform of the first order of of the derivative of the I1 and I2. Now I'm gonna rewrite um, in the form of the capital I and capital I1 and capital I2. So the first one we get S times I1 plus 50 times I2 equals the Laplace of the number. I put a note here. The Laplace of 60 is 60 times 1 over S or 60 over S. Okay. Then the right hand side of the first one is 60 divided by S. The second equation, we have S I2 plus 200, 200 I2 and minus 200 I1 equals 0. Write them in the systematic way. Now we get the S, uh, just move the terms or rearrange it. Then, let's see. This one may be convenient to do the substitution, but I did the systematic way anyway. So SI1 plus 50 I2 equals 60 over S, and move the I1 align with the first equation, and the second will be S plus 200 times I2 equals 0. And now we just think about what we're gonna eliminate I1 and I2. It looks like easier to eliminate the I1, right? The I1, because it has its S and negative 200. So multiply the first one by 200, multiply the second one by S, and then add them up. Next, we get, since the I1 is gone, so 200 times 50, yeah, we deal with the last number, be 10,000 times I2 equals 200 times 60, that is 12,000 divided by S, and then added by, I have to make some room, sorry. Um, since this one gone, and then have to add by the S times S plus 200 of the I2. So plus, so S times, do step by step. I2 equals 1200, 12,000 divided by s, sorry. So that's what we got. And then uh, collect the coefficients of the I2 s times s, that s squared plus 200 times s plus 10,000 times I2 equals 12,000 divided by s. And next, divide all by the coefficient of the I2. Looks like the coefficient of the I2 is in the perfect square form of the s plus 100 square. Okay, so we're gonna go to the next slide. So the I2 equals divide all by s plus 100 quantity squared. We get the 12,000 divided by s multiplied by s plus 100 squared, and fall into the same pattern. Break it up into the partial fractions. The quantity divided by s plus the quantity divided by, since this is the linear with the power 2, so gonna have it as two partial fraction. The first is power 1, the second is the power second. Okay, linear power 2, so power 1 power 2, and all linear, so the numerator gonna be just the constant a, b, and c. Okay, go ahead. You are comfortable with symbol lab by now, right? And again, the capital I2 is the Laplace of the current I2.
So I got A is positive 6/5.
6/5. Oops. 6/5. Okay, thank you, Josie. Go ahead.
And then B is negative 6/5.
Okay,
And then C is 120 or negative 120.
thank you.
Yep.
No, and Andrew, you got the same numbers, right?
Yep, that's what
I
I got.
assume. I assume. Okay, thank
Yep.
you. So then the current I2 is the, put the coefficient 6 over 5, the inverse Laplace of 1 over s, negative 6 over 5, the inverse Laplace of 1 over s plus 100, and minus 120, the inverse Laplace of 1 over the quantity s plus 100 squared. Okay, the first one, not a big deal, right? So we can see this as the, uh, this one is a constant, and this one is the s minus a. So a is negative 100, and this one we have the translation, if you recall. So this is the same as the inverse Laplace of 1 over s squared, where s translates to s plus 100, and your a is negative 100 as a translation. Let me rewrite it. So this is s minus the a. Therefore, the a is negative 100, which is what we saw in 7.3. Now put them all together. So the I2 is 6 over 5 times 1, or 6 over 5. The next is negative 6 over 5 e to the negative 100t. And then the second one is, since the Laplace of 1 over s squared is just the t or t to the first power, and then multiply by the translation, which is the e to the power at. So plus or minus sign, sorry, minus 120 e to the negative 100t from the translation multiplied by the Laplace of the 1 over s squared. So the translation occurs. So we multiply by e to the negative 100t. Okay, so this is the current I2. And then after we get the current I2, you guys have question for the last part here. So this I would refer you to see 7.3. Yeah, 7.3 about the translation. So next we're gonna find I2 and pick and choose again from the Laplace transform um, of the to find the solution for the I1. Okay. From what we have, looks like the, I'm gonna go back to see we have, it's convenient to use the first one to solve for I1. What do you think? You can use either one of them, it doesn't matter. You have S, you have 200 for the second part for the coefficient, the I2, but the first one is more the direct forward and only one of the I2 that you're gonna use. So I'm gonna, I make a decision to use the first one. Okay, so from the first Laplace form, from S of the I1 plus 50, I2 equals 60 over S. That means your I1 is 60 over S minus 50 of the I2 and divide by S or multiply by 1 over S, or just 60 over S squared minus 50 over S, and the I2 with the Laplace transform before we do the partial fraction. Where did it go? There you go. Is 12,000 divided by S times S plus 100 power 2. And then simplify. I give you what I got, which is 60 multiplied by S plus 200 divided by S times, this is a simplified form. Okay, so S times S plus 100 to the power second. So I let you work on the detail if you are curious how to get there. And the capital I1 is the Laplace of the current I1. Therefore, we're gonna do the partial fraction of this. And quick one, use a symbol lab, and we get, well, we already run out of time, so I'm gonna give you what I have. So 6 over 5 over 6 fifth over S minus 6 fifth, almost the same as what we got again. And then the last term is negative 60 divided by S plus 100 power 2. The last one will give you the translation in in the axis, in the in the s axis. So then the I1 equals 6 over 5 minus 6 over 5 e to the negative 100t and minus 60 times e to the negative 100t multiplied by t as the solution for the current I1.